So friends, I welcome you again all to my video tutorial. It has been some time that I have not been making video tutorials. It has been a gap of around 6 to 7 days, but now I am back. In the topic of numbers, I have covered till LCM type 1 questions. Now it is a continuation. I will tell you about the LCM type 2 questions. I told you about the 3 types of LCM. LCM type 1 question, LCM type 2 question and LCM type 3 question. So this is the second type of LCM questions. So the point is here we have to see that what basically these questions are of type. So I have written the question here. Please jot it down in your copies and I will read this question for you once again. It says that a number which when divided by 3, 4, 5 leaves a remainder of 2, 3, 4 respectively. Now I would like to point it out here, the division that has been talked about in this question is individual division. It is not successive division. I already told you in the previous lecture also, in the LCM type 1 also, it was individual division, not successive, and in this it is also individual division, not successive division. Successive division I will take up later on in my videos. So here it means that suppose the number is n, and it says that when this number n is divided by 3, the remainder will be 2. It says that when this number n will be divided by 4, the remainder will be 3. And similarly, it says that when this number n will be divided by 5, the remainder will be 4. This is what whole thing is implied here. That means that we have to find out that number n which when divided by 3 leaves a remainder of 2, which when divided by 4 leaves a remainder of 3, and which when divided by 5 leaves a remainder of 4. So I hope you have written this question down in your copies, and this question finally has 3 parts. We have to find out the least possible number of this form, we have to find out the least possible 4-digit number of this form, and we have to find out the largest possible 4-digit number of this form. Now these are the 3 questions that I have given you. You have to solve it in this manner. So the point is that if you have written down this question, now I am going to rub it and I am going to show this to you in a more general form, and after writing that question in a general form, I will come back to this question and solve it. I will write out divisors are 3, 4, 5, just to remember it. Now, suppose divisors are something like this: A, B, C, and remainders are something like this: P, Q, R. So the point here is that divisors are ABC, remainders are PQR. What is the question? The question is the same, that a particular number n which when divided by A leaves a remainder of P, that number n which when divided by B leaves a remainder of Q, and that number n which when divided by C leaves a remainder of R. So these ABC is the set of divisors, these PQR is the set of remainders. It is very much clear that I have assumed the general values as ABC and PQR. In the previous question that I have written here, I have assumed the value of divisors as 3, 4, 5, and I have assumed the values of remainders as 2, 3 and 4. So here the value is more general. So in order to find out that this number, what will be the form of this number, I am going to first explain it to you in a bit detail. Suppose if the divisor when number n is divided by A is P, so it means that when we divide n in groups of A, P items are left remaining. It means simply that when we are going to divide this n in groups of A, then P items would be left out which cannot be divided into groups of A. Similarly, when we divided n by B, it means that we are trying to divide these n quantities in groups of B. B must be some number, and we are trying to divide this number n in groups of B, and in this process Q articles are left which cannot be divided in groups of B. And similar goes for the third process. that we are going to divide n in groups of C, and there are articles that cannot be divided into groups of C. Now try to relate it that with this 3, 4, 5 and 2, 3, 4. Suppose this was the case that this is the divisor, this is the remainder. The question says that suppose the number was n, that when, and I suppose that this n is not a number, this n is some sort of quantity, suppose n balls. Now if we divide this n by 3, it means that we are trying to divide these n balls into groups of 3 balls. This is what we are trying to do. So if we are going to divide these n balls into groups of 3 balls, then what the question says that the remainder is 2. It means that if we are trying to divide these n balls into groups of 3 balls, then at the end there are 2 balls that are left, that are remaining, and these 2 balls cannot be arranged in groups of 3. This is what question means. Similarly, when these n balls are being tried to be divided into groups of 4, 3 balls are left that cannot be divided into groups of 4. And similarly, when this n is divided into groups of 5, there are 4 balls left which cannot be divided into groups of 5. So, in the first case the extra is 2, in the second case the extra is 3, in the third case the extra is 4. Now that is like this, something like this. Suppose n is divisible by, n is divided by 3, something comes here and the remainder is 2. So what does this mean? That when n was divided into groups of 3, 2 was remaining. That 2 cannot be arranged. So what we can do? Either we can reduce this 2 from n, then we can say that n minus 2 will be divisible by 3. This we can do. Or what we can do? Suppose, what we can do? That how much amount is more needed? I am repeating, how much amount is more needed in this n in order to make it divisible by 3? So in that case, how much amount is more needed? 2 was there. 2 items were not being able to divide into groups of 3. If I take one more item, then obviously this will become n plus 1, and then we will be able to divide n plus 1 into groups of 3 according to the condition given in the question. So how much lack is there? The lack is there, divisor minus remainder. The lack of 1 is there. This is what I am trying to explain here. This means that when we are trying to divide some amount of quantities into groups of 3 and 2 are left remaining, that means that those 2 quantities are extra and they cannot be divided into groups of 3. So obviously the groups are of 3 and at the last only 2 quantities are left. So in order to convert that group of 2 quantities into the group of 3 quantities, how much I have to add? I have to add 1. That extra I have to add 1. And from where will I get that extra? I will have to subtract this remainder from the divisor. That I have done here, 3 minus 2. Because this is the number in the groups in which I have to divide, and this is the extra item. So how much I have to add so that this becomes equals to this? 1. That is 3 minus 2. This is the whole logic here. If it was 5, suppose, if it was 4, so it will come out as 3. Same logic here. When n quantities are being tried to divide into groups of 4, 3 quantities are left. This means that 3 quantities at the last have come extra and they cannot be divided into groups of 4. Therefore, in order to convert a group having 3 quantities into a group having 4 quantities, I have to add 1 extra quantity. This is the simple logic. So in order to do that, what I can do? I could add 3 with 1 and 4 I will get. That means we can say that 4 minus 3. If I add 1 extra to this number n, then this n plus 1 will become divisible by 4. The same logic was in the previous question. If I would have added 1 to n, then n plus 1 would have been divisible by 3. And if I would add 1 to this, then n plus 1 will also be divisible by 5. Because here also, when I am trying to divide these n quantities into groups of 5, 4 quantities are coming extra. So this is the whole logic behind this thing. The main point to see here is that in this case, the difference of the divisor, that is 3, and the remainder 2 is 1. The difference of the divisor 4 and the remainder 3 is 1. The difference of the divisor 5 and the remainder 4 is 1. So what is common? Their differences are common. What is these differences? This is that number which, if we add to the original number n, we will get a number which will be exactly divisible by 3, 4 and 5. simultaneously. This is my whole logic. So the concept says that suppose, coming on to the general term, the divisors are ABC, remainders are PQR. Now, if we calculate the difference, I am writing a difference. So I calculate the respective difference between the divisors and the remainders. Then what will I get here? I will get A minus P. Obviously, I am supposing that these remainders are less than the divisors. I am not going to the concept of negative remainders. It has been supposed that the value of PQR is less than A, B and C respectively. So A minus P, what will be the difference here? B minus Q. What will be the difference here? C minus I. So the condition, the LCM type 2 condition says that the respective difference between the divisors and the remainders is same in all the cases. So what we can say? That A minus P will be equal to B minus Q will be equal to C minus I. Let us suppose it equals to K. Supposition. This I have supposed. This quantity K is an assumption here. That A minus P, B minus Q, C minus R is equals to K. Let. So we can say that the question belongs to the set of LCM type 2 when the respective differences in the divisors and the remainders of the pair of number is equal. Here 3 minus 2, that is the original question. 4 minus 3, 5 minus 4. It is coming equals to 1 in each case. So obviously the differences between the divisor and remainder is coming equal. So what we can say that this is LCM type 2. So in order to solve this, I will write the general term here of this equation. First, we are going to find the LCM of the respective divisors. What are the divisors? ABC. So first we are going to find out the LCM of A, B, C. And outside it, I am going to put a constant. Now the point is that here I suppose the constant as, suppose K2. So here I am going to suppose the constant as K1. This you know. What does K1 means? It can be 1, it can be 2, it can be 3, it can be 4. And there K2 is an arbitrary quantity. So what we find out? LCM of ABC outside bracket K1. In the previous question also I have used K. So what now I will write? In this I will minus this difference. Now why I am subtracting this difference? What was the reason for subtracting this difference? The reason for subtracting this difference is that in this whole question what has been said to you, that a number which n, when divided by A leaves a remainder of P, divided by B leaves a remainder of Q, divided by C leaves a remainder of R. So the point is here that P, Q, R are the positive remainders. You can say that P, Q, R are the positive integers, remainders, but A minus P is the negative remainder, B minus Q is the negative remainder, C minus R is the negative remainder. The point is, okay, first note it down because I need some amount of space to write this on the board. So please, I hope that you've written it down in order to understand, in order to make it understand to you. I am rubbing this thing and then I will explain to you with a live example. Suppose that I will go smallly into the small, up to a small quantity into the numbers, into the remainders concept. I think most of you would be pretty much sure about this thing. Suppose a number I have 48. I divide this number by 7. Okay? I am dividing this number by 7. What I can write here? I can write 7 6 is 42. I will write here 42. What will be the remainder? 6 will be the remainder. So the point is, one way of writing 48 is equals to 7 into 6 plus 6. This is one way of writing. 48 can be replaced 7 into 6 plus 6. But if the question is that if I am dividing 48 by 7, that what will be the remainder? So if I am dividing 48 by 7, the remainder is 6. Now look at it in the other direction. 48. If I divide it by 7 and I write here 7, then what will come here? 49. And what will be the remainder in this case? Minus 7. We know, I have already told you in my previous video tutorials that negative remainders are not possible. Because the mathematical convention says that remainders also always have to be positive only. Remainders cannot be negative. So in this case, remainders cannot be negative. But this minus I have taken us to in order to make a concept of remainders, in order to get you guys acquainted with the concept of negative remainders. Because this is also right, we can also write 48 as 7 into 7 minus 1. This is also the way to write this thing. So minus 1 is the remainder here, 6 is the remainder here. Now the point is here is that, look at this thing. In the previous concept, in this question, 48 is divisible by 7, remainder is 6. Now, we can say that if we are trying to divide these 48 quantities in groups of 7, 6 quantities are coming extra. 6 quantities cannot be divided into groups of 7. So in order to divide a group of 6 quantity into a group of 7 quantities, we have to add 1 quantity to this group. And from where this 1 came, that I am going to find the difference between these two things. Because this was the group into which the things have to be divided, this I got. So how much are left? This much are left. That 1 has to be added. So here what I have done? Here I have taken a multiple which is 1 greater than 6. So it came here 7, but now minus 1 has came. What is this denotes this minus 1? This minus 1 denotes that if I have done 7 into 7, I have counted 1 digit extra and I have to subtract it. So the point is here that if this 7 minus 6 1 was added to it, it should have become divisible by 7. So here in this case, in the general form of LCM type 2, the general form becomes LCM of ABC into K1 minus of difference. In the previous LCM 1 model, what I told you, in that case, in all the cases the remainder was same. So what I did LCM of ABC into K plus remainder. That was what I did in the previous video itself. But that remainder I added because it was direct remainder. Here, this difference is not the remainder. The remainder was different in each case. 3 divided remainder was 2, 4 divided remainder was 3, 5 divided remainder was 4. So the remainders were different. So, and the remainder was not common. In the LCM type 1, the remainders were common in all the questions, in all the cases. But in this case, the remainders are not common. The divisors was also different, the remainder also different. What is the difference between LCM type 1 and LCM type 2? In LCM type 1, the divisors were different, but the remainder was common. In LCM type 2, the divisors are different and the remainders are also different. But the respective difference between the remainders and the divisors in each of the cases is equal. So the point is, what I am trying by finding out the difference between the divisor and the remainder, I am trying to find out the negative remainder. And that negative remainder I have added here. So I have added the negative remainder, it becomes minus difference. This is the whole concept here. So please write out this form of LCM type 2. K1 into, this K1 is a constant, please write it as constant of proportionality. Now, I hope this much amount of thing is clear to you, and if it is not clear, now I am going to solve that question, which I told you at that time. Then it will become very much clear to you. First jot it down in this way. I am trying to understand this is the very basics of numbers that I am taking up. This is the very basics of number, because in my subsequent lectures I have to go to a bit higher concept of numbers. So here I am trying to tell you the idea of numbers in the most detailed format, so that in future you are able to cope up with it in a bit fast manner. So what did the question say? Question said n divided by 3, remainder 2. n divided by 4, remainder 3. n divided by 5, remainder 4. 2, in order to make it n divisible by 3, what I have to add? N 1. Because in order to make a group of quantity 2 equal to group of quantity 3, I have to add one quantity. That is 3 minus 2. Here 4 minus 3, here 5 minus 4. All of these are equal to each other. So 3 minus 2, 4 minus 3, 5 minus 4 equals to 1. So what will be the form here? The form here will be LCM of divisors. What are the divisors? 3, 4 and 5. So LCM of 3, 4, 5. What is the constant that I can take here? K1 minus difference. What is the difference here? The difference here is 1. 3 minus 2, 1. 4 minus 3, 1. 5 minus 4, 1. So what I will write here? 1. So this is the form. What will be the LCM of 3, 4 and 5? The LCM of 3, 4, 5 will be 60. It will become 60 K1 minus 1. So this is the general form of this equation. The rest part of the question I will cover in my next video tutorial. Thank you.